All right, welcome. Now this is 8.6, day 2 notes. And we're going to start by reviewing something that we learned in 8.4 a few days ago. So let's have log base b of y is equal to x. Now we know this translates to b to the x power is equal to y. Now I'm going to add some fine print here. It's going to say b cannot equal 1 and y is greater than or equal to 0. So in this problem here, b cannot be 1. Now this is why. Think about it. If b is 1, it doesn't matter what x is. Y is always going to be equal to 1. Alright, so let's say x is 2 and y is 16. So if I have b to the second power is equal to 16, we know b has to be 4. But if I tell you b is 1, it doesn't matter what x and y is. Because no matter what, x could be 10,000. And my result is still going to be 1. So when dealing with logs, our b cannot be 1. And if you think about it, when I just write log, we know the base is 10. We've never seen a base 1. And that's why, because it's impossible. It really doesn't make much sense to do 1 because we're only left with one solution. Now, y has to be positive. Now, this is why. Think of if you have log of negative 8 is equal to x. So right now, I have my y equaling negative 8. All right, everybody see that? Now, this is impossible because you have log base 10 of negative 8 is equal to x. So when I rewrite this, I get 10 to the x power is equal to negative 8. Well, there is no possible value of x that would make that negative. Even if I put a negative exponent, it just means we put it over 1. Right? So that is impossible. So you can never, ever, ever take the log of a negative number. Okay, now, these two minor details are going to play a huge role in today's lesson. All right, so it's very important to remember this. B cannot be 1, and you cannot take the log of a negative. That's the easiest way to remember this one. You cannot take the log of a negative. All right, so I'm going to do 4 examples today. 3 of them are going to be review of what we did in yesterday's video, and one's going to be a new one that really takes this into consideration. And then tomorrow in class, we'll do a few more, and we'll talk more about this because I understand it's kind of an abstract concept to get across in the video. All right, so let's look at our first example. Log base 2 of x is equal to negative 1. So this time, remember, we want to get rid of my log. So to get rid of my log, I have base 2. So I'm going to raise both sides to the second power. I'm sorry, put a base 2 and raise that to my power. So now I'm left with x equals 2 to the negative first power. And 2 to the negative first power, we can't leave my answer like that, so it's 1 over 2. We bump it downtown. All right, example 2. Let's go 2 plus 8 times the natural log of x equals 30. 2 plus 8 times the natural log of x equals 30. So let's subtract the 2. So 8 times the natural log of x equals 28. Let's divide by 8. So I have the natural log of x is equal to 28 over 8, 7 halves if you divide them both by 4. All right, now I got to get rid of my natural log, so I'm going to take e as my base. My natural log's gone, and I'm left with x equals e to the 7 halves. So let's go ahead and type that in our calculator. Second ln, second natural log is e to the 7 halves equals 33.115. So x is 33.115. All right, so just reviewing some solving. A few more. All right, number 3. So 3 minus 2 log base of 3 of x equals negative 7. So subtract your 3. Negative 2 log 3 of x is equal to negative 10. Let's divide by negative 2. So log base 3 of x is equal to 5. All right, we got to get rid of log 3. So I'm going to put a base of 3 on both. and I'm left with x equals 3 to the 5th power, which is 243. All right, now let's have some fun. Number 4. Let's go. Log of 5x plus log of x minus 1 is equal to 2. Now, excuse me. To start, let's condense this. We have a plus, so addition we know is multiplication. So I have log of 5x times x minus 1 is equal to 2. Now we want to get rid of this log, so we know it's base 10. So I'm going to base 10 each side. Right, that gets rid of my log, and I'm left with 5x times x minus 1 is equal to 10 squared is 100. So I'm going to distribute my 5x, and I get 5x squared minus 5x is equal to 100. Let's move that 100 over so we can factor and solve. All right, so when I go to factor this, the first thing I look for is a GCF. So I take out a 5. I'm left with x squared minus x minus 20 is equal to 0. Two numbers that multiply to negative 20 and add to negative 1 is x minus 5, x plus 4. And you still have your 5 out front. So my two solutions are x equals 5 and x equals negative 4. Now, whenever we get solutions, we have to be careful now to check for extraneous solutions. All right, check for extraneous solutions. And remember, what that means is what makes this problem impossible to solve. All right, so when we check for extraneous solutions, we're checking for these two things. Okay, is my b equal to 1, where I can't solve it, or am I taking the log of a negative, which is impossible? So when coming back here, I have 5. Let's check 5. So log of 25, that checks out. 5 minus 1 is log of positive 4. That checks out. So 5 is the solution. Now negative 4 would be log of negative 20 plus log of negative 5. Now, we cannot do that, again, for this reason. Okay, it's going to be impossible to get that to equal one another. All right, so negative 4 is an extraneous solution. So again, we have to check to see what makes the log negative. And if it does, it cannot be a solution, and that would be our extraneous solution. All right, so tomorrow when you get to class, we're going to talk about this more, and we'll probably do 1 or 2 more together just to make sure you have a really solid handle on this. All right, thanks. See you tomorrow.